Okay, let's see be a circle x squared plus y squared minus 16x minus 6y minus 152 equal to 0. Let R be the center of C. Part A, find the coordinates of R. It's quite simple, just use the formula directly, okay? Before using the formula, you need to make sure that the coefficient of x squared and coefficient of y squared equals 1. B, prove that Q, negative 815 is a point lies outside the circle C. And C, point P is a point on the circle C closest, okay, underline this word, closest to Q. Describe the geometric relationship between R, Q, and P, and hence find the coordinates of P. Part D, another point T is a point on the circle again, so that the area of RQT is the greatest. Describe the geometric relationship between R, Q, and T, and hence find the perimeter of triangle R, Q, and T. Okay, let's look at the solution. Part A will be very straightforward. Coefficient of x over negative 2, and then coefficient of y over negative 2. Then you get the center is 8, 3. And B, you need to prove that there's a point outside the circle. So, first of all, you find the radius of the circle, that is coordinate of x squared plus coordinate of y squared, and then minus the constant term, and then take square root, that's 15. So the radius of the circle is 15. And you find the distance between the center QR and another point Q, that is 20. Since it is greater than 15, therefore, you must have this one. You must have this comparison. You must write it down. Therefore, Q is outside the circle C. So let's go to part C. You want the circle with the point P, which is closest to point Q. That means, first of all, Q, P, R will be line on a straight line. Actually, they are collinear, okay? Because point P can be moved on the circle, but you want it to the closest to Q, so it will be here, something like this. They lie on the same straight line. And how do we find P? You can use point of division. Negative 8 times 15, that's the radius of circle, plus 8, the center of the x coordinate of center, multiply 5. Now how does it 5 comes out? Distance between QR is 20. Distance between P and R, that's the radius, is 15. So 20 minus 15, that is 5. Okay? So 8 times 5 over 5 plus 15, that's 20. Okay? You are doing the same thing in y coordinate. 15 times 15 plus 3 times 5, and then over 20. Then you get the coordinate of P, that is negative 4, 12. Okay, let's look at part D. There's another point T, so that the area of triangle RQT is the greatest. So look at here. Area of this triangle TQR, actually that is QR times TR times sine angle TRQ, and then over 2. Okay, so you will get that is 150 times sine angle TRQ. That means the area of this circle is controlled by sine angle TRQ. And when would sine angle TRQ be the greatest? That is when angle TRQ is 90 degrees. Some of you may say, how about over 360 degrees? Okay, that's not possible, because when you are talking about a triangle, the maximum angle should be less than 180 degrees. So here you will say If I want sine angle TRQ be the greatest, that's 1, then angle TRQ should be 90 degrees. Therefore, QR is perpendicular to TR. You should answer this way because the question asks you to describe the geometric relationship between R, Q, and T. So, you know that is the right angled triangle, then you can find QR, RT, and then QT. You can find QT by using Pythagoras theorem. So, the perimeter will be 20 plus 15 plus square root 20 square plus 15 square. Then you will get the final answer, that is 16. So that's the end of the question.